So today we're going to make a door handle. We're going to use the lathe, the mini mill, and we're also going to tap some threads for anchorage to the actual door leaf itself. So first things first, we're going to go ahead and try to turn this down to a uniform diameter. We're going to inevitably have some knurling at both ends with a decorative pattern. This clean part in between will be where we will put a leather grip. So we'll go ahead, first step is to get everything chucked up. You'll notice that there's quite a bit of material cantilevered out. We're going to center drill this. Normally on something this long out of the chuck, you would have to put a steady rest on the back side, or a fall arrest actually on the back side. We're going to be taking extremely light cuts so as to avoid the need for that, but it's good practice to put a fall arrest on the back side on something this long. But once now that it's chucked up, we're going to center drill it, and I'm going to test real quick to see how wonky it is here. It's actually pretty good. So I'm going to go ahead and center drill that, and then we'll take off some material and get a uniform diameter. Okay, so what we have done to get to this point is we've done two major operations. We've taken a roughing pass, and so let's just quickly talk about the roughing pass before we confuse the roughing and the finish pass. So the roughing pass is going to be, in terms of RPM of the spindle, somewhere in the middle of the range from 65 to 1150. I typically will, my general rule of thumb is start in the middle for roughing, and then in this case, it's roughly 560 RPM. And that's, again, how fast this is rotating. In terms of how fast do I want to move the saddle, you can come down here to this chart. So 60T or 30T, it's depending upon the gear setup. The concept is the same. So the best thing to do is say, okay, I'm going to limit it to 60T. Down in this corner is the slowest the saddle will go. Up in this corner is the fastest. And so somewhere in the middle is typically where, again, I'll start with my roughing pass. And so on the finishing pass, what we'll end up doing is changing the gears to a faster speed. I know 560, kind of halfway in the RPM range, is a good roughing pass. And so when you start to go faster, in this case you go 730 or 1150 would be your two other choices. Start with 730 and look for signs of failure. If you're doing okay, go to 1150. On your finishing passes, you want to take very light cuts. You're barely taking off material, okay? And then over here, in terms of your saddle speed, you basically just set it as slow as it can go. So B, C, V. Over here would be B, C, V. And that's how you set up the machine for the roughing and the finishing passes. So we have a knurling tool here in the shop. It's not the best knurling tool, and so we have to make some provisions to kind of help shore up the lack of integrity this tool brings to the overall system. So what we have discovered we need to do is we need to shim the bottom, because you can see the difference between the 16 millimeter shaft on that tool holder and the thinner, probably 10 millimeter shaft on this. So we're going to just use a stack of shims. We're going to place those shims under it. Also, the 10 millimeter dimension in this presents a problem relative to the tool post right here. So effectively what I'm going to do is I'm going to stack these shims up like so. I'm going to use this drill bit because it's a uniform dimension down its length. I'm going to put that up against there after backing this out. Stack those shims up, put this in like so, and then also I'm going to effectively jam this knurling tool up against the tool post, all for rigidity. Again, because machining, rigidity is your best friend. Okay, so we've adjusted the knurl in the tool post such that the jaws are open. What we're going to do is advance the cross slide so that this knurling tool is situated and sitting right on top of the apex of the curve, or 12 noon if you look at the end of the part and think about a clock face. So we're going to engage the part right there, and we're just eyeballing this. It's not super precise, okay? We're not measuring anything necessarily. It's all by eye. We've positioned using shims, as we mentioned earlier, such that the distance between these two fulcrums, pivot points, are about splitting the part, so about 9 o'clock on the dial there. Okay, so now we're going to start to, and why don't you come around here and look at the bottom. You can see when I turn this, we're going to engage the part just like so. I'm going to do finger tight, and now I'm going to take this drill key, chuck key. I'm going to tighten it about 1/4 of a turn or less. Okay, and that's gripping the part. Now what we have to do is change the RPM of the spindle to the lowest speed on the machine. Okay, so 65, so B1. Okay. Now for this operation, I'm going to use the jog, and I'm just going to do like 1 or 2 complete turns. And now I'm going to look at the pattern that's been developed. You can see it looks really actually pretty good. So one thing that I need to do now that I like it is I'm going to squirt it with some WD-40. And that's going to basically keep the debris from clogging up. It's going to help keep the debris from clogging up the channels of the knurling wheels. Okay, so we are starting to accommodate for the leather, on the handle. And so what we want to do is we've decided to remove material on the handle so that the knurling that we just put in is going to be coplanar or flush with the leather. So that implies that what we have to do is find out the thickness of this, which is approximately 1.7 millimeters. That's an average we kind of took over the leather because it varies in thickness. So we've determined that 1.7 millimeters is the average thickness that means that we have to take 1.7 times 2, which would be 3.4 millimeters off the diameter of the part. And we went ahead and did a journal cut that got us from a diameter of roughly 24.42 millimeters down to about 21.02 millimeters as the smaller radius that you can see there. So we're going to repeat that on this end, and then what we're going to do is we're going to take off material between those two journal cuts. And these journal cuts just offer us a positive means of stopping before we get into our nice finish piece of metal that we don't want to mar up or accidentally cut. I'm feeding this in very slowly. And the WD-40 is there just to help prevent chip weld onto the cutter. I'm using the slowest RPM possible for this parting tool. Parting tools are famous for breaking. And so constant pressure, shot of WD-40 to help prevent chip weld. You can hear that high-pitched whine, that's called chatter. And the way to solve for chatter is a little bit more pressure. Or slow down the machine. Those are your two options. And we can't slow down the machine because we're already going as slow as possible. So you can see on these deep cuts, slow speeds that are these roughing passes with the carbide, it's not a good finish. It's really not at all good, but that's not the point right now. The point is just to hog off a lot of material to get down to the point where we can do our finish pass. And so I'm going to set up for a finish pass at a high RPM and a very slow travel speed on the saddle. Tell me when. Okay. Okay, that's at 1.28. Let's just go round that up to 1.3. Okay, that's 1.3 right there. Okay. What I did there is I backed off, so I don't want to create a pinch point. That'll certainly break the cutter. So now you can see it starting to wobble, and it's going to break it any minute. There it goes. Okay, so the finished product. We started with this raw stock. We turned it down initially to make it perfectly round, because this shape isn't perfectly round. It looks round, but it's not. It's more of an oval. So we made it perfectly round, so we had a uniform circle we could measure and index off of. We then proceeded to knurl the ends right here. After knurling, we went ahead and did journal cuts, which are these lines here. We did a journal cut here too, and here too, to establish starting and stopping zones for the removal of the bulk of the material here. So we removed that material to accommodate for the leather. So we should have a mostly coplanar relationship between the outer surface of the leather and then the knurled ends here. We initially had decided to make the height of the knurling area or zone the same on both ends, but we have a longer one here, and we were going to turn and face this end down to match that, but we decided that visually it felt better to have a more like a heavier, more substantial foundation or base to it, almost like when you mount a picture in a picture frame. You allow for a little bit more of room here at the bottom of the piece, your eye and the way your eye reads an object. So we decided to leave a little bit more there, and we finished the process with facing the ends to make a nice pretty top, as well on the bottom. That little hole there is a remnant from the manufacturing process. It was our center drill and our live center end, and since that is facing down, you'll never see it. It's no big deal, and that's our handle.